Okay, cool. Ready to go?
Yes, let's do.
Awesome. Cool. Thank you so much. It's great to see you all again on this beautiful morning or afternoon, depending on where you're at. Maybe it's the middle of the night. Either way, I applaud you guys for being here. Thank you so much. I think everyone was here, but everyone should know me. My name is Kevin. Today, we're going to be talking about a little bit more like smart contract stuff. We're actually going to try to build a smart contract. And then my goal is also to show you guys the integrations with Base. So first, we'll start with that. And we can talk a little bit about the different options that you have. This thing's asking me what language I speak. I speak English. Okay, all right, cool. I don't know why Zoom was asking me that. That's the first. Ask me what language I speak. Okay, so yeah, we're gonna get started. Let me go ahead and share my screen. Oh, I need sharing privileges, Celine.
Yes, sorry. All good.
No, no problem. Cool, awesome. All right, now I can share. Okay, cool. So I added just a small little blurb here to the curriculum, which I'll just send that out just in case so that people have it ready right now. But basically, we're going to be showing off the Scaffold-Base, which is like a special build of Scaffold ETH. And then I'm also going to talk about the extension system, which is a way to like extend your build with some kind of added functionality. And the reason I want to talk about that is because we're going to use the extension system tomorrow when we talk about the subgraph extension and the graph. So we're just going to kind of preface that a little bit, and then we're going to go through this kind of like smart contract workshop. Okay, so Scaffold-Base is basically, so if we click this, Scaffold-Base is a special branch of Scaffold ETH. It's got its own GitHub repo, so it's available here on the link right here. And that's one way that you can use Base directly with Scaffold ETH. Technically, with the base version of Scaffold ETH, you can deploy to Base. I think we saw that yesterday, the base version on Base. We saw that yesterday you can deploy to Base Sepolia or you can deploy to Base mainnet on that branch. But these two have some direct integrations, some kind of like cool little branding inside of the Scaffold ETH that you'll see. And then on top of that, the extension system has like the ability to do like smart wallet stuff, which I think is valuable if you're like, trying to do something like that at a hackathon. So anyways, we're going to do this. So we're going to clone down the repository just like we normally would if we wanted to set up Scaffold ETH using Git. And we are going to go into that directory and then install all the dependencies, right? So let's go ahead and do that real quick. And we're going to open up a window here. And I already have kind of my windows set up, but we're going to do git clone Scaffold-Base, and then we're going to go into that directory, Scaffold-Base, and do a yarn install. So that's going to install the dependencies and all the requirements. Might take a second. It's basically just like you're setting up scaffolding. This is the general way you do it. It's just going to add in some additional code that looks very friendly for Base. So we'll give that a second. Hopefully it doesn't fail. Okay, cool. So now we're going to do the same thing. We do yarn chain to spin up our front end, go into the Scaffold-Base directory and do yarn start. So it's the same exact setup. So after we have that set up, then we go into the same directory and we're going to install or deploy the contract, right? So Scaffold-Base is where I checked it out, and we're going to do yarn deploy. So that's going to take the same contract, it's going to deploy it to the local chain, which is running in hard hat. Okay. We'll get into the code here in a second and take a look at it. But first, let's actually just go ahead and look at the actual Scaffold ETH app. So just like Scaffold ETH, it's on port 3000. And the first time you load it up, it's going to basically compile the root directory. And then it's going to show up here in just one second. Okay, cool. So this is Scaffold-Base. So as you can see, it looks almost identical to Scaffold ETH. Nothing really too crazy here. I guess the biggest thing is that there's some extra links here on the homepage. One is for the superchain faucet for Optimism, and one is for the base faucets. So if you want to get some testnet ETH, you can get it pretty easily by going to either one of those. Um, you still have the burner wallet functionality, and you still have the way to get funds from the local machine, right? The local thing. And you still have the debug contracts tab. So it's pretty much the same thing. It's still Scaffold ETH. It's the same contract, all that stuff. The only difference is it's kind of branded a little different. And it's got the ability to do the on-chain kit as well, which is also, I believe it's actually part of the normal version of Scaffold ETH, but we can show it off real quick. So I'm going to disconnect from my burner wallet here. So as you can see, we have this ability to disconnect, and we click our Coinbase wallet. Okay. So Coinbase wallet will pop up, and then it will give you the ability to sign in or connect a wallet. So if it's your first time creating a Coinbase wallet, you can click sign up. In my case, I already have a passkey, so it should let me just click passkey. And I can literally just put my finger here on my laptop and it will sign me in with my passkey, which is really, really cool. So now it's going to allow me to connect. I just have to approve that. And I think this should work. And now it generates me a wallet using my passkey that is tied to my finger on my laptop. So the way, if you guys don't know passkeys, they're kind of like private keys that are stored inside of the local machine uh, on your machine, right? So in this case, I generated a passkey last time that I set this up, and I've since then I've closed this out and done a lot of things, but still my passkey is tied to this particular public address. So that's really powerful because then I can back up this private key to my own methods. Like I could write down the password or I can put it into a vault or something like that. But whenever I want to get it back on this machine, I can just use my finger to do that. So that's really powerful for yeah, for I guess user experience, right? Because there's none of this like remembering the 16 words and having to type those in or 12 words. And then on top of that, you can start to build in like features around account abstraction in the future, which just will be like a better user experience. Okay, so disconnect and I can connect back. And if I want to connect back to my burner wallet, I can. So Scaffold-Base is just, like I said, a special branch of Scaffold ETH. It has, the branding, it just looks a little different. You can still do the passkeys on the normal version, but for today, I just wanted to use this to do our kind of like little workshop. Okay.
Someone asked me a question about wallet verification on Coinbase.
Wallet verification.
On Coinbase, so
Let me look real quick.
the
Wallet verification.
is like an open.
Yeah, so I think you can also like, I'm not too familiar with how it works, but you could do Coinbase Wallet. Let's see if I can actually configure this. Yeah, so you can like connect to a wallet as well. You can click connect, and I think you can sign in with your Coinbase account. Um, yeah, this is actually not the right thing. Let's see. Sign out. It's been a while since I used this, but let's see.
So I have my mobile wallet on my mobile phone, obviously. So I signed it with the QR code. I basically had to scan the QR code in the
Ah,
Coinbase app, and it connected to my wallet.
there you go. Yeah, so you could do it that way as well. So basically, like this on-chain kit is kind of acting as like well, I should say your Coinbase wallet on your phone is acting as like an auth provider. So you're connecting from this app to your phone's app, and that kind of establishes the connection with Coinbase because you're already authenticated. So yeah, I don't know how did you get to that, by the way? Because for some reason now it's just defaulting to passkeys for me.
Yeah,
Uh,
because I think you have to completely log off
ah,
because I had the same issue. I have created, yeah, and now try again.
see if that works. Oh, there we go. Okay, yeah, there we go. So sign in or connect wallet, and then yeah, you can use mobile app. Good job. So then if I use my mobile app right now, I could scan this. Cool. Thank you. Cool. So anyway, so that's a cool integration with Base. Let me hide these meeting controls. Good questions. Good questions. Okay, so let's use this version of Scaffold-Base, but let's just go ahead and connect our burner wallet because we can just use that for right now. So one of the things that I want to talk about is just kind of like the thought process, I guess, that when you go through. So this, sorry, real quick, this side quest here to set up Scaffold-Base is really easy. You guys can do this and you can do exactly those steps pretty easily by yourself. I would recommend you do that just to get familiar with it. But we're going to be focusing now on the smart contract workshop. So the goal of today is that we want to deploy a token, an ERC20 token. So I want to walk through the thought process of like how you decide on like what you need to create for a token. And then I want to talk about like the different ways you can do it. I guess the easy way and then the harder way. And either one works. And I'm just going to kind of give you guys the answer. We're just going to kind of walk through it, and then I can answer questions in probably like the last like 20 minutes, 15, 20 minutes about this, and then also about the challenge one of the Speedrun Ethereum challenge. Okay. So let's just kind of go through this. So basically what I want you guys to do at some point, it doesn't have to be, you don't have to follow along, but if you can, I would like you guys to use the Scaffold-Base project that you guys set up in that side quest and use that as your kind of like Scaffold ETH environment. And I want you to come in here and basically kind of get good at like starting at a base contract. So I think we kind of went over this a little bit, but what I want you guys to do is kind of clean up the existing contract so there's nothing inside here. We want to just kind of empty it out. And we want to just kind of make it easy to read and kind of just save that and then learn. I think you guys already know, but the deploy script, right? You might have to make some changes here to the deploy script. So what I like to do is just right away, I come in here and I make sure to get rid of this deployer so that we're not passing that deployer key like we did yesterday. And then I also like to take out this console log because that's going to cause a problem. I still like to keep a copy of the contract here, and we'll explain that why in a second. But I always like to do the deploy like we do, and then keep a copy of the contract available in case I want to interact with it in my deploy script. And then now we have this kind of like base starting contract. Okay, so you should be able to get to this point really easily now, especially if you followed along yesterday. So I'm going to save that and just do a redeploy, and we're going to do reset. Okay, so what do we want to do? We want to, so the instructions for the workshop, these instructions, when I wrote them, were supposed to be in like a class setting where basically we'd like kind of like break away and everyone would stop and do this. But I think for the sake of today, we're just going to walk you through it again because I think you guys are learning really well in that way by like watching me kind of do things. But you guys can try to do this on your own later on if you need to as well. So basically what we want to do is, so up to here, I walk you through that. I say, okay, well, clean out the contract so there's nothing there. Actually, I think I added these two parts, which we can put those back in if we want to, which are here. Doesn't really matter, but the constructor and that receive can be there. And then we can redeploy again. But anyways, we want to just get to a very simple contract and then update the deploy script. So important that you remove the arguments here. And then important that you remove the instance of the contract, or the console log, I should say, and then deploy those changes, okay? And the next thing I'm going to explain in the docs is like how to do ownership. I think I talked about this yesterday, but forgive me if I did not. But one of the key benefits of using like open Zeppelin contracts is that we can like reuse functionality, right? And so I always use the ownable contract. I always use this one no matter what on every single contract I ever create because I want to be able to take ownership of the contract, especially if it's something that I'm going to deploy to a public test net. And I want to be able to make sure that I can, get money out of that contract in the future, right? You need to be able to have access to it. So ownable is important. So I always that's another thing I always do is I say your contract is ownable and make sure that I'm inheriting the ownable contract after I import it here, right? So if I save that and then do another deploy, we can take a look at Scaffold-Base and let's take a look here. So we are connected, just reloaded. We can go to debug contracts. And so now that I've kind of inherited an open Zeppelin ownable, you'll see that I get these two new functions, right? I get the ability to renounce ownership and transfer ownership. So the first thing I want to do is make sure that this private key that's here is the default, I should say it's the very first private key that's being used by Hard Hat to deploy the contract. So it doesn't actually match my burner wallet. My burner wallet's up here. This address is like a shared private key and public key pair. So we don't want to keep this as the owner because then anybody who has this private key can get access to it. So what does that mean exactly? So it basically means that because this particular account is the hard hat account that's deploying my contract, right? It's the deployer. So it's this deployer that's right here, which is coming from the named accounts. We actually want to transfer the ownership of the deployer or of the owner at the time. So when the contract is first deployed, it's the deployer. So we need to call this transfer ownership function that's available to us right here. So we have this as part of the ownable. So if we look at ownable, we can actually click it here and look. If I hold down command and click on the contract, I can see. But particularly what's important is that we get the owner based on whoever sends the actual transaction to create the contract inside of here. So we need to transfer that ownership. So let's come over here. And because here we get a copy of the contract, we can transfer the ownership using that instance. So how we do that is we say await. So basically says like, make sure that this particular command completes before you finish and close off the next command. So we can say your contract. So we have access to the contract. So we can say your contract dot transfer ownership. And then we can put in any address that we want in here. Okay. So you could put your MetaMask address in there. You could put your Rainbow wallet, Coinbase wallet address. It doesn't matter, but it just should be a private key that you own and you hold, right? It's private key, right? So copy address, and I'm just going to paste that in there and hit save. Okay. So now what's going to happen is it's going to deploy my contract just like normal, but it's going to get a copy of the contract to interact with, and then it's going to transfer the ownership of the contract. Okay. So let's deploy, and then we'll have this kind of, now we can go back and see that the owner here matches the burner wallet. So if we go to Block Explorer, we can see exactly what happened on here on the bottom. We can see here where the contract is created on this one right there. And we can see here where the ownership was transferred, right? So we can see that since I've set up my chain, there's been 11 transactions. And this was where the ownership was transferred. So it was transferred from the hard hat account to me using this. So now I have ownership access to this contract. So if I wanted to, I could actually renounce ownership. So you might have heard this idea of like throw away the keys, right? Like you basically say, well, I wrote this smart contract. I want it to live forever and no one will ever be able to delete it, right? That's how you do that. You renounce the ownership and it writes the owner as all zeros. So 0x000000. So if I come in here and get some funds from the faucet, I could say renounce ownership. And now the owner is no one. No one owns this contract. That's just locally. But that's a really powerful thing. Now, if this was on an Ethereum blockchain and you did that, no one could stop it. It is truly an immutable and censorship resistant application. Okay. So really cool, but no one can also get the funds out of the contract. So you need to be careful with that and don't call this unless you absolutely mean it to do that. Okay. So now we're kind of at this very base starting point. Any questions at all?
Yeah, from Lucilla.
Any questions? I see there might be some questions. Yeah.
Yes, yes. So Lucilla asking, can we transfer ownership for the challenge 0 contract too?
Yeah, I mean, you've probably already deployed the contract. So technically you could probably, if you still have the project there, you could change, but you probably would need to get the private key and you would need to call the transfer ownership inside of like some wallet that you integrate in it. It'd be hard to do because probably already, yeah, you already did it. If it's a test net, you know, it's not, this is just one of the best practices when you get to mainnet. Not to say that, you still should use your own private keys for testnet as well, but it's still possible. So still haven't been able to get enough deployed past zero. They have a bunch of Sepolia ETH. Okay. All right. Aren't all smart contracts immutable? Um, so technically speaking, when you say immutable, like can last forever, yes, but they can technically be self-destructed. So you can actually take a contract and you can kind of like stop it usually by like some form of a transaction to actually kind of like self-destruct the contract. There's ways to stop contracts if the private key is held by someone. So technically speaking, that's what the proper way to write a smart contract in a truly censorship resistant way is to not make it upgradable. However, there is a proxy pattern that you can do where you can like create one contract and then you deploy a second contract behind it using a special implementation, Ethereum implementation called EIP. I think it's 242. I cannot remember the address or the protocol. Do a proxy contract. Some protocol probably want to have, but the users will know that, hey, you could always upgrade the code. And so there's always this chance of like protocol changing and maybe you'd be less likely to use it. Whereas something like a smart contract that is written fully, to the point where it runs on its own, it only runs once, it lives forever. It's kind of powerful. So, yeah, good questions. Okay, cool. All right. So let me keep going and then we'll see if there's more questions as we get to the end. So this should be like your kind of like starting point for a contract. Okay. So you should always kind of just blank everything out, make sure you get ownership of the contract so that you have access to get any funds that get stuck in it or anything like that, and then kind of go from here. So what we want to do is write a token, an ERC20 token. So the general idea of an ERC20 token is that you have some kind of supply of a particular coin, and then you want to be able to like transfer those things around. Okay. So you can do that pretty easily. So let's kind of just write it out real quick. Let's go up here to the top and let's go ahead and say, all right, first of all, we want to define like how many decimals that our token should have. So as you know, like Ethereum, ETH has 18 decimals so that it can be broken apart into like smaller chunks. So we can say uint 8 and we can say public sorry, public. And we can say decimals equals 18. So we can just do like the same as Ethereum. We can also name the particular name of our token. So in this case, we'll just call it your contract sure, like AI is just kind of taking over. We can also choose a symbol. So like ETH is the symbol for ETH. We can use YC, which would be like for your contract. And then we can also say like what the total supply is. So we can say uint 256 total supply. There we go. And I don't know, that's just randomly created this particular thing. This is actually wrong. What we want to do is do 10 times the decimals. So the uint 256 decimals. So in this case, we have 18 decimals for how many zeros, leading zeros that we want to have in our particular token. In this case, I don't know, let's do 777,000, I don't know, just to be fun, 2, So 777,000 tokens with those decimals. So here we say times 10 to the 18th power, right? So basically 10 times is to the power of 18. So here we're going to create a token that is 777,000 times 10 to the 18th power, which is a lot of tokens. So we're basically just creating a supply. It's just a number really that we're creating inside of our smart contract. And we want to just have that number available for people to use inside of our contract. So the next thing is we need to be able to assign the value of those numbers. So we might want to keep track of that, right? Because we want to know who has how many tokens at any particular time. So the way we do that is a mapping. So if you look at, actually, let's go ahead and look at mapping real quick. So if we go to Solidity by example, and we go to mappings, where is it at? Mappings. So mappings allow us to take one variable and then map that to another variable. So I showed this at the very end of yesterday. The most common way to do that is using address, mapping an address to a particular integer. You also might want to do like a whitelist on an address, would be like an address to a Boolean. Like, is this person able to use this application? True, false. So this is what we're going to use actually for our balance. So let's do that. So let's do mapping. Here we go, balance of. So we're going to use the balance of. So we're going to say that any address, we want to map the balance of their tokens to an unsigned integer, and we're going to make that available publicly in a balance of. So this is the same thing that you get when you do an ERC20 token. So at this point, we have the ability now where we have this like number, this like kind of like this big number of tokens available. Now we can start kind of like managing who has access to those tokens. And then we also probably will want to add events, but we won't do that right now. But at the time of the deployment for our ERC20 token, we need to send the total supply to somebody. Okay. So we probably need to say who that supply is going to be. So let's actually do an address for that. We're going to do address public, I don't know, owner equal. And then I think we need to put it in quotes here. Let's grab our burner wallet. Let's do this. Copy that. I think we need to do it like this. No, actually, we need to do it just like this. I think that should be a word, right? Oh, I might have to do payable. Let's see. Let's see what Copilot says. No, that's not right. There it goes. Now it worked. I don't know. That was weird. There was some kind of weird. No, that should be a word. Maybe I have to do payable, something like that. Hmm. Oh, it's because I'm using ownable and that is reserved. So let's just say I don't know, like supplier or supply owner, something like that. There we go. Okay, there we go. So it was because owner was being used by the ownable, so it was already reserved. So what we can do is at the time that we deploy our contract is we can basically give all of the supply to a particular user. And so the way we do that is we call the mapping, the balance of, and we say balance of the supply owner here, which is what's divided here, is equal to the total supply. And I don't think we need to do this payable actually. So technically, if you're going to like try to send value inside of a contract, it needs to be a payable address, but we'll get rid of that because I don't think you need that. And so now we have the ability at the time of our deploys to like mint that supply. Now all we need is a way to like transfer the supply around. So we need to be able to like say, well, I have all the tokens. I need to send them to someone. I want to send like 100 to this guy. How do I do that? So that's pretty easy. All we have to do is just come below the constructor and add a function to transfer. There we go. Thank you, AI. You got to love AI. It's great. So it's going to, first of all, it's going to take in an address of where we want to send the tokens to. And then it's going to ask us how many tokens that we want to send. And if I don't have a balance, so one of the next things you learn, or one of the important things you learn in Solidity, is you want to have a require statement to protect your function from any kind of misuse, right? So we don't want someone to be able to send tokens if they don't have the balance of tokens. So what we do is require that the balance of the sender, the person that's actually calling message.sender, is that global variable, we talked about that yesterday, is greater than or equal to the value that they're trying to pass in the function. Otherwise, insufficient balance, right? And then we're going to subtract that balance or that value from their balance, and we're going to add to the other person's balance that we're sending in the to address. Very, very simple, right? And then I guess we could we could do something like this where we could say like Boolean success. So like if it's a successful thing, then we say like return true, like that. I think that might work. Let's try that. Oh, I say we have to do returns. Okay. So what this is saying, like, all right, we're taking in these variables and on success, return a Boolean and only return true if it's successful. So we know it's successful when this happens right here. Okay. So let's save that. And I think we're good enough to just like kind of test it and see if it works. So let's do that. Yarn deploy reset. So we kind of just walked through like in our brain of like what we needed to do to create a token. And it's a very basic implementation. Okay. So now we have all that stuff inside of our debug contracts. So we have a balance of, so we should be able to check the balance of this address here and see how much we have. There we go. We've got 777,000 tokens in our balance. And I can transfer some. So if I want to send some to Vitalik, and I'm going to send him 777. Oh, 777. And I need to convert it to Way. I don't know if we talked about this much, but I think Austin probably talked about it. We need to transact in Way. So the way you do that is you take a big number, you should take a little number that you want to transact in that token. So in this case, we know that our token is 18 decimals, and we have to multiply the higher value of the ether into Way. So we multiply it by 10 to the 18th power. So we click this little button, it will do that for us. So this is how much Way is 777 ether. So we click send, and there we go. So now if I come over here to the balance and I check Vitalik.eth balance and hit read, we'll get his balance, which is 777 ETH, right? Or in this case, he has 777 YC tokens, which are your contract tokens. Yeah, that's it. That's basically what a token is. It's a way for you to just assign a really random generated or a random number or it's not a random number, but a defined number, and then transfer that value around. It's a very basic ERC20. There's a totally easier way to do this, and that's using OpenZeppelin. So let's try to do that with OpenZeppelin. Let's get rid of all this stuff real quick, and let's just show the easier way. So let's say we also want to import at OpenZeppelin ERC20.sol. Now we can say our contract is ownable and ERC20. Okay. Now this is going to give me an error because I don't have any arguments passed into my ERC20 constructor. So we have to have that. So let's do that. So let's say constructor and ERC20. And there we go. And we need to pass in some stuff into the ERC20 constructor. So what does it want? Let's see. It expects 2 arguments, but we haven't given it any arguments. So there's 2 arguments we need to pass into it. The first one is the token name. So in this case, your contract is the name, and the token symbol is YC, right? I think that's what we did earlier. And then same thing, we need to do 777, 1, 2, 3. And so this is, I think we need to do that. Actually, I think we can just do like this. There, okay. So this is everything we just wrote in that kind of like long code is just transformed into this code. Let's see if it works. But this should be the easiest way to do an ERC20. Let's see if it works. It should get the same exact kind of stuff, but we might have minted to the message sender. We actually need to mint it to the address that's here. So let's do it up here. Let's grab this, copy address. And yeah, there we go. So we actually want to mint it to that one. So let's save that and deploy again. Cool. So now we should have our token just like we had the other token, just by using a different way to do it. There we go. So same thing. We have the token called your contract. Symbol is called YC. It has a total supply of 777,000. But look what we get. We get more stuff in our contract that we can reuse. So not only do we have the transfer one that we hard coded in earlier, we also have the transfer from, which allows us to transfer from a address to like a smart contract or another address to another address using the allowance or the approve option. So approve pattern like is basically where you have to like approve the spending of tokens. For the case of like, we have a contract that's maybe acting on your behalf, like DeFi, something like that. But you get the idea. Like it's basically a full implementation of the ERC20 that's written for you, and it's a lot easier, right? So always just think and see like, hey, is there a way to do something a little bit more simple with Open Zeppelin contracts and try to use that because it can make your life a lot easier, right? And there's all sorts of different examples to do stuff like ERC 721 for NFTs, which you guys learned about already. ERC 1155s, which are like kind of like semi-fungible tokens, which allow you to do like token gating stuff. And yeah, and there's tons of standards. I would recommend that you guys just take a second to look at Open Zeppelin's contracts on GitHub. So if you go to Open Zeppelin contracts, and you can look on here and see all of the different contracts, and they're available in this contracts folder. There's ones on governments, access control, proxy, like someone asked about upgradable contracts. So there's an example of using the ERC 1967 proxy, which is the upgradable contracts. So there's lots of stuff that make it easier for you to understand. Okay, so that's pretty much all I wanted to show off for the token stuff. But I think now what I'd like to do is maybe just stop and see if anyone has questions. And then on top of that, maybe we can start talking about the first challenge and see if anyone has questions or if anyone's stuck.
The,
How does
the
that
top
sound, Celine?
questions are interesting. So if you can take a look at the chat.
Yep, let's see. All right. Thank you for putting the ERC 1167 as the proxy contract. Great. Everything in Solidity should have 18 decimals. No, it doesn't have to have 18 decimals. I think that's just like the common and the largest like amount of decimals you can have. But there might be an instance where you don't want to have 18 decimals. Some people have only 9 in their token or something like that. It really depends on how much your total supply is and how many tokens you want to mint, but it does not matter. It's just also easier to interact with a lot of the tooling because it's kind of default is 18 decimals. So most people use that. If you don't know how to code right now, try to understand the smart contract logic. Yes, that's very important. Open Zeppelin. Does Scaffold-E support proxy contract debugging? So if you add a proxy contract, it's not going to show up automatically inside of debug contracts unless you've done it inside of the hard hat deploy. So if it's like, in other words, if it's like a public contract and you're just inheriting the address and you don't have access to the ABI, then it's not going to let you kind of do much debugging. So yeah, only way it's going to let you really do like detailed is if you actually have the contract there. And you're, basically compiling it locally, and then you'll have it in the debug contracts tab. Just for curiosity, if we don't want a function from the Open Zeppelin contracts to work in our ERC20, can we disable it? That's a really good question, Sandra. And yes, you can override inherited functions. So if you inherit a specific contract and you want to completely disable a particular functionality, like a good example is some people want to do soul-bound tokens, right? They want to do like ERC 721 tokens that cannot be transferred. So what they often do is import the Open Zeppelin ERC 721 standard, and then they create another transfer function, and then they override that functionality that basically would cause it to automatically not allow a transfer, like it would fail no matter what. So yes, there's definitely ways you just use the override functionality of a function. I couldn't understand why we needed to have 18 decimals here. So the reason why we have 18 decimals there is because you don't want to have, like, if I want to send you a token, and I don't want to send you maybe the whole token, I just want to send you half of a token. That's why we have the decimals. It allows you to break up and divide that one single token. In other words, like, let's say I wanted to pay you for your car. You selling me your car, and I want to pay you in ETH, right? Well, I can probably send you a fraction of an ETH to make it exactly worth what it's worth. So I probably need to send you, let's say I need to send you 10.01 ETH. I wouldn't be able to do that without decimals, right? We need to be able to break it down into way. And so that's why we need decimals, is to break down tokens into smaller amounts. Just like we need to be able to break a dollar to pennies, we need to break down a token into way. And the more you can break it down, the more flexible it is, and the more room there is for the price and the cost of that token to go up. Is there a list of projects that use Scaffold ETH well? Yes, there's a whole bunch on the BiddleGiddle website. So if you just go to the BiddleGiddle website and then there's a build section. Yeah, if you go to biddlegiddle.com and then you go down to the bottom, there's like a project section as well. Okay. Yes, Open Zeppelin is really good. I think did I answer all the questions, Celine? Is that good?
Yeah, that's okay. Just I was looking for something for OpenZeppelin, like how we can custom a smart contract. So um, I would just send you something on the chat.
Okay, cool. Okay, yeah, let's take a look at it.
Yeah, yeah. When you
Cool. Mhm.
scroll down, you can, for
Oh yeah,
example, customize an ERC20, etc.
yes, this is awesome. I forgot about this. Thank you. Thank you, Celine. Yeah, this is really cool. So this is really useful. Like if I want to say, like someone asked about overwriting. So let's say I want to do an ERC20, but I want to make it let's see here. I thought there was a way to do like non-transferable on here. Mintable, burnable. I guess there's not a way to do it on this for the transferable, but like let's say you want to use access control and you also want to do roles, or maybe you want to do roles instead of access control, or if you want to pause the contract and maybe you want to be able to yeah, make some kind of change to the URI or the token. We can call it the H.E.R DAO token. Cool. Yeah, so it will actually build a contract for you. Really, really useful. And all of the Open Zeppelin contracts should be installed on Scaffold-Base. So you should be able to use any of these tokens to do that. Very, very powerful. Cool. All right, let's take a look real quick at the speedrun Ethereum. Let's go here. Cool. So challenge zero should be easy. I think you guys all probably knocked challenge zero out of the park, right? Challenge one is a little bit harder, but I want to walk through the idea and just make sure you kind of understand what is kind of asked of you. Just like you normally set up Scaffold ETH, get it up and running, and really the challenge starts here at checkpoint one. Okay. All we're doing with this contract is we're creating a list of balances, which we did that earlier, from an address to an integer. We're also tracking what the threshold is of how much ether that they need to be able to, I think, stake, or whether they hit the threshold. And then we need to be able to create the stake functionality. I don't want to give you guys the answer because I think you guys need to figure this out. But if you get stuck, we can help you guys remotely. Everyone who is stuck, please join the Challenge One Telegram thing here if you are stuck, and ask your questions in there, because that's going to be the best place to get like quick support. I'll try to keep an eye on it today as well. But we want to create this stake function, right? That allows us to put in some way and stake that into the contract, right? And what I always tell people is actually let's clone this repository real quick. Let's set it up. I want to just show you guys real quick a little trick. So let's clone this. Sorry. So let's go git clone and let's call it SE2 challenge one. Sure. SE2 dash one. There we go. So you're an install. Oh, I need to check out the right branch. So we need to check out this branch. Oh, I gotta delete the yarn log file and yarn install. Okay, there we go. What I want to show is particularly, and we haven't really covered this too much, but inside of the packages hard hat folder, there's a test folder. So we're using hard hat test for hard hat, and we're using the Foundry test for Foundry. In this case, all the challenges are written in hard hat, but this TypeScript is kind of like the answer to the challenge. So this is actually going to tell you exactly what needs to happen in order for your contract to succeed, right? So you should be able to say, well, yarn test, and it will give you the answer. So let's just set it up real quick. So if we go yarn chain and yarn start and go into this and yarn deploy dash reset. So I have the chain up, I have the front end up. Now I'm deploying. It's downloading the right compiler for me. So in this case, we're using Solidity 0.8.4. So it had to download the compiler. So I deployed the contract. If I do yarn test like this, it will take that test file and it will run it against my contracts and make sure that it's going to pass when I actually submit the challenge. So this is very powerful because basically all the answers are here inside of the tests. So if you can get these tests to pass properly, then you're going to be able to submit your thing. So look at these tests and shoot, plug them into ChatGPT if you want, and they'll basically explain to you exactly what they're checking for so that you can kind of see, like in this case, we want to see that the balance is a starting balance of this much. Then we need to be able to stake. Then we need to be able to wait a little while. And then we need to check the stake again and make sure that it's gone up. Has the balance gone up? If not, make sure how much it's gone up. So this is a very good kind of like yeah, like a way to just kind of verify like what you're doing is correct, like reverse engineering. So that's just my advice to you guys. Let's see if we have another question. Yes, it's a very much amazing hand. No one knows it, but I love you guys. So I'm hooking you up. Okay. Any other questions? So I don't want to, like I said, I don't want to give you guys the answer like I did yesterday because I think there's a lot of value in you guys going through and doing this on your own. But we have like 8 minutes left, so I think it's better we just use these 8 minutes to help you guys. So feel free to come off mute or feel free to ask more questions. So do we have to understand TypeScript for this new challenge? Absolutely not. TypeScript is really just the way that we're testing the file and that TypeScript file that I just showed you. And then on top of that, like the front end is written in TypeScript, but we don't actually have you make any front end changes. You don't really do any front end changes until you get like to challenge like 4 and 5 of Scaffold-Base Speedrun Ethereum. So for this one, you don't need to know TypeScript. You should know TypeScript because TypeScript's amazing. But eventually you'll get there. Don't worry. Just right now, focus on Solidity and like understanding how the smart contracts work.
Yes, so the goal is not to become a great dev in 1 week. It's just to understand the basic step. And yeah, no worries about the things that you see. It's with the time you will be able to do things really great. No worries.
Yeah, definitely. I mean, it's just a journey, you know. I would say that even me, like I didn't know TypeScript very well, like up until like recently, even in the last like 6 months to a year. And I've been like an engineer for a long time. I knew JavaScript obviously, but TypeScript takes you a little while. So don't feel like you need to be an expert in any of that stuff. Just kind of like be able to understand it from a high level, and then eventually you'll get better and better. And the idea is that scaffolding just makes it easier for you. The next question was, can we join the Build Guild to be contributors? So, well, we used to have like a pretty open system with the Build Guild, like pretty much anyone could join after like so many challenges. After you hit challenge 5 and you build a Dex and you complete that, you can join the Build Guild. So if you get to that point where you do challenge 4 or 5, you'll join the Build Guild. And then you'll basically want to reach out in Telegram and explain like, hey, I'm building. I've kind of gone through all these challenges, and you can start working with the Build Guild and do some cool stuff. And yes, TypeScript is great, Lucila. I highly recommend it. Cool. We have 5 more minutes. So what else can I help you guys with? Okay.
Mm, I know some people get an issue with the requirements at the beginning. So to install Node.js. So if you want to just explain for Node.js and npm and Git, so really.
Yeah, for sure. So Node.js is pretty easy. If you just Google install Node.js, it just depends on your machine. But all you could do is come here and choose what OS you want to install it with. I think I have version, let's see, no dash dash version. I'm using 18, so I'm using like an older version, 18.24 L2S. And then you can install it if you're using a Mac. Highly recommend using Homebrew. Homebrew is like the easiest way, in my opinion, to install any package because it's just like seamless. So if you have Homebrew, if you don't have Homebrew, you can say install Homebrew and go to the Homebrew website. And there's just this one command you need to type on your Mac to install it. So highly recommend that. So install Homebrew first. And then here you can install it using Homebrew. If you don't have Homebrew, another option is NVM. Okay. NVM is Node Version Manager. Really, really useful to have Node Version Manager as well. It kind of just depends. Like I always install like the base version of Node.js with for Homebrew. If I start to have issues and I need to change my version of Node easily, Node Version Manager is also very useful. These are the commands to run it. It's very simple. Now, if you're using Windows, it gets a little trickier. I'm not the expert on Windows, but it might be better to download the package installer, pre-built installer, and then choose like what operating system you have here, and which version of Node, and then to download the pre-built installer. If you're using a package manager with Windows, you can run into like little weird quirks. So it's really just up to you, like what path you want to take and what you're more comfortable with. But the pre-built installer for Windows is probably the best bet. So you just choose what architecture you have and what version you want. Again, 18 is fine. Some people say 20. 22 is the most current version. Um, I don't know. Sometimes people have bugs with most current version, so I tend to stick with either version 20 or 18. Okay. And then for Node, sorry, totally blanking right now. Yarn.
Yeah.
Install Yarn. You can just go to install Yarn and that will pop up here. For Windows, chocolatillery. Okay, that sounds amazing, but okay, so there's a chocolatillery app. Okay, cool. Sorry, I'm just trying to read the comments right now. Yeah, use terminal to install like the command line stuff. Yeah. Um, so Lucila recommends 18. Yeah. 18 works better with, it's more compatible with stuff. But sometimes you need to upgrade to 20 for some reason. I don't know. I don't know what you're using it for. I think for like the graph we use like version 20 works better, but how do we know we submitted the challenge? That's a great question. So if you come to Speedrun Ethereum and you go to the challenge one and you go all the way to the bottom, you can hit submit challenge, put in your URL for the where you deployed your contract and where you deployed the Vercel application. And then when you submit, you can go to your profile and it will show up right below it. So it'll say challenge one, and it has a link to the code and the demo, and it says whether you have submitted it and whether it was accepted. So if you submitted it and it was not accepted and it failed, it would say failed. If there's a comment, you can click the comment. It basically like automatically creates a comment letting you know that the challenge passed. GitHub repository for Scaffold-Base. Yeah, there you go. Thank you, Bora. Appreciate that. And it's also in the Notion page. Do we need to be sure about our smart contract before we do yarn deploy? Probably for mainnet only. Yeah, unless you're just worried about wasting gas on like test nets. But yeah, always just make sure that your contract's in a really good state before you push it to before you YOLO it to prod. Yes. All right. Does the challenge have trials? Not sure I understand trials. Well, I mean, you can always, if it fails, you can resubmit it. So don't worry about, yeah, like if you've, yeah, you can resubmit it. Why do we make the team fork just for base? We made the fork just for like branding for like our workshops, and originally all the on-chain kit stuff and the Coinbase Smart Wallet stuff was only in that fork, but now it's kind of been moved over. So it was just originally like an experiment, I guess. We also have one for like ZK Sync that we were working on. Yeah, I think the idea is like appealing to a certain chain by having the faucets and stuff like that. But yeah, I don't think it's not a huge big deal. It's just, yeah, it's more of like we were hosting events and wanted people to use like that branded version pretty much. And like I said, it was more of like an experiment, like a test bed. Cool. All right, we're over. So I appreciate you guys. Thank you so much. Tomorrow we're going to be focused on the graph. So tomorrow's like the graph. I'm going to do a 10-15 minute overview of what the graph is and why it's important. And then on top of that, we're going to actually set up the graph integration, and I'm going to show you how it works. Cool. Thank you so much, guys. No, you guys are awesome.
Thank you,
Huge
Kevin,
shout out. Yeah,
for
good
your
job.
support. Everyone really appreciates your work for you. So yeah, thank
No
you.
problem. Yeah, and I'll see you guys tomorrow and try to, oh, the homework for today is to try to do challenge one. We are officially on challenge one. So try to do it. And if you get stuck, ask in the Telegram chat. And if you need ETH, paste that also in the Telegram chat. I know that Austin sent some, but just let us know. Okay. All right. Bye, guys. See you later.
Bye bye.